Mastering Python Multiprocessing, Queues versus Shared Memory Explained. Learn how to optimize parallel processing tasks using Python's multiprocessing queues and shared memory, enhancing your skills in high-performance computing. Welcome to our deep dive into Python's multiprocessing capabilities. Did you know that Python can handle multiple tasks simultaneously, optimizing performance for CPU-bound applications? In this video, we will explore how mastering queues and shared memory can supercharge your Python projects. Stay tuned to discover how these tools can help you optimize parallel processing tasks effectively. The Python Multiprocessing module is a powerful tool for running multiple processes simultaneously, allowing you to fully utilize your CPU. Unlike threading, which can be limited by Python's Global Interpreter Lock, GIL, multiprocessing creates separate processes, each with its own Python interpreter, allowing for true parallelism. This makes it ideal for CPU-bound tasks where you want to maximize performance. Setting up the multiprocessing environment in Python is straightforward, and we'll guide you through the process to ensure you're ready to dive into practical examples.
In the world of Python multiprocessing, queues and shared memory serve as crucial tools for inter-process communication. Queues allow for easy and safe passage of data between processes, making them ideal for tasks where data order and integrity are crucial. Shared memory, on the other hand, provides a space that multiple processes can access simultaneously, which is perfect for large data structures that need to be shared without the overhead of copying. Understanding when to use each method is key to optimizing your applications, and we'll explore their differences in detail.
Queues are a fundamental part of Python's multiprocessing toolkit, providing a robust way to exchange data between processes. They ensure data integrity by maintaining order and preventing data loss, making them ideal for tasks that require reliable data transfer. Common use cases include producer-consumer scenarios, where one process generates data and another processes it. Implementing queues in Python is straightforward, but there are common pitfalls to watch out for, such as deadlocks and data corruption. We'll guide you through best practices and troubleshooting tips to ensure smooth operation. Shared memory is a powerful tool in Python's multiprocessing arsenal, offering the ability to share large data structures between processes without the overhead of copying. This efficiency is especially beneficial for applications dealing with extensive datasets, such as scientific computing or data analysis. By allowing multiple processes to access the same memory space, shared memory facilitates faster data access and reduced resource consumption. We'll walk you through the implementation process in Python and highlight scenarios where shared memory can significantly enhance performance. Let's dive into the practical side of things by implementing multiprocessing queues in Python. We'll start with a step-by-step guide on setting up a basic queue, followed by code examples to illustrate common operations such as putting and getting data. Understanding how to handle exceptions and errors is crucial, as is optimizing queue performance to prevent bottlenecks. Whether you're new to Python multiprocessing or looking to refine your skills, these examples will provide a solid foundation for leveraging queues in your projects.
Setting up shared memory in Python involves several steps to ensure efficient and safe access by multiple processes. We'll provide Python code examples to guide you through the setup process, including how to synchronize access to prevent data race conditions. Avoiding common pitfalls, such as memory leaks and access conflicts, is essential for maintaining application stability. We'll also share best practices for optimizing shared memory usage, ensuring you can leverage its full potential to enhance your application's performance. Even seasoned developers encounter challenges with Python multiprocessing, but understanding common pitfalls can prevent many headaches. We'll cover typical issues such as deadlocks, data corruption, and synchronization errors, providing troubleshooting techniques to resolve them. Effective debugging practices, including using Python's built-in tools, can streamline the process of identifying and fixing problems in your code. Additionally, we'll point you to resources for further learning, ensuring you have the knowledge needed to tackle any multiprocessing challenge.
Optimizing performance in Python multiprocessing involves a combination of strategies to balance speed and resource consumption. We'll explore techniques for maximizing efficiency, such as selecting the right tool queues or shared memory for your specific task. Understanding scalability considerations is key, as is monitoring and profiling performance to identify bottlenecks. By implementing these best practices, you can ensure your applications run smoothly and efficiently, making the most of your hardware's capabilities. Congratulations on reaching the end of our exploration into Python multiprocessing with queues and shared memory. We've covered the essentials to enhance your CPU-bound applications, empowering you to take your Python projects to the next level. We encourage you to apply these skills and share your experiences in the comments. Don't forget to like, share, and subscribe for more content. Let us know what topics you'd like to see next, and stay tuned for the next video in our series.